Alright, so our post-test, which is coming up here on Friday for 2018, it's a large chunk of your final exam, so it's a huge part of your overall score. And I think sometimes kids forget that. So make sure that you are hitting this hard. I'm going to do all of the A's on this review packet, leaving you with the B's to do, but please do check your work on the answer key. So this first question, I'm just asking you to naturally solve it, and we don't really like fractions, right? So what I would suggest you do is, instead of distributing this fraction, what if you were to multiply it, oops, not by that, by the reciprocal of that fraction? So instead of 3/2, you'd flip it upside down and make it a 2/3. So what happens is, if you multiply, remember, like this is one side of the equation, right? If you multiply both sides of the equation by 2/3, over here on the left side, the 2 over 2 and 3 over 3 cancel, and the x minus 6 is now just by itself, isolated, and 12 times 2/3 would be an 8. And then you're going to add 6 to both sides and get x equals 14. Now I do want to warn you that the question on the test is an error analysis question where, you know, someone has done the work and they've messed up, and you have to describe like what they did wrong. So just a little insight for you, the most common mistake on this question is somebody who tries to divide by the fraction. So like they'll type 12 divided by 3/2, and they'll type it like this in their calculator, and that's not the proper way to type it in the calculator, so they end up actually multiplying instead of dividing. So they either should have multiplied by the reciprocal, or it's possible that when they divided by 3/2, they still could have got it correct if they used parentheses around the 3/2. Oops, I don't know what I'm doing today. Ugh, Monday. Alright, so keep that in mind as far as error analysis. And of course, on that question, guys, when you know it's an error analysis question, don't ever tell me that the kid did it right, because they never did. Alright, so solve and graph this inequality. We have ands versus ors. Remember, if you have a less than or a less than or equal to in an absolute value question, you are looking at an and question. If you have a greater than or a greater than or equal to for the absolute value inequality, you have an or. So this one here, because we have a greater than symbol right there, that means we have an or. And we're going to set up two problems. We're going to set up x minus 7 greater than or equal to 13. Just take the bars off, and then make sure the word or shows up. X minus 7 won't change, but you do, remember, two things you change. You flip the sign around, so now it's less than or equal to, and then you negate the answer. So now instead of 13, it's negative 13. So, of course, we're going to add 7. Oh, man. Probably should have waited a few minutes for my coffee to kick in before I got this question done. So I am tired. Okay, so your inequality solution is x is greater than or equal to 20, or make sure the word or shows up in your solution, x is less than or equal to negative 6. So in my brain, I'm thinking about what an or should look like. Negative 6 shows up first on the number line. Ors are the ones that are supposed to kick out away from each other. So everything greater than or equal to 20 would be this way. But because it has an equal to bar, because of this guy right here, we're going to be using a bracket on the 20. And then similarly for the negative 6, everything less than or equal to negative 6 would look like that. And then your interval solution, just make sure you're reading it left to right. So we think about, okay, where did my shading start, and then where does it end? It starts at negative infinity, and then it keeps shading until negative 6 with a bracket. And then you jump over a bunch of solutions that don't work by hitting a union symbol. And then it picks up again at 20, and goes to infinity. So I like having the number line before I have the interval solution. That's kind of why I wrote the question that way, so you guys would have all the parts building up to the final solution, which technically the interval solution is the only solution an Algebra 2 teacher would want, but this time I want them all. Alright, we're going to do all the A's, remember. So here, this question, this is on a recent test, and you guys actually did really nice, except some of you had a little trouble with the algebraic section. So remember, we're using both methods to solve the same question. So the algebraic method is the one that most kids have the most struggle with. If you square both sides, the square and the square root functions are inverses of each other, so they just cancel. So you get x minus 1. And then over here, you have an x minus 3 squared, which means you have an x minus 3 times another x minus 3. So I would encourage you to just slowly FOIL that out so we don't make any mistakes. X squared minus 3x. And then you're going to have another minus 3x. And then negative 3 times negative 3 is positive 9. And then I do notice we have a quadratic, like we always have on this question. And we're going to subtract x over here. I'm also going to add the 1 over here. Alright, so finally I get to clean this up. You have a quadratic, x squared. This is the part that I always get nervous about for you guys. We have negative 3x minus another 3x and then minus another 1x. So you have a minus 7x. I don't know how many times I've seen people do like 3 times 3, which obviously is not right. Alright, and then plus 10 at the end. And this quadratic for our questions should always come out factorable. So I'm looking for numbers that multiply to positive 10, but I need the arches to add up to negative 7. So what if we tried a minus 5 and a minus 2? So when you solve both of those factors, right now I have 2 solutions from the algebraic method. I have x equals 5 and I have x equals 2. But we're going to go check it through the art of graphing, which means on my calculator, more than likely, because we are stressed out, so I understand wanting to use your technology. You're going to graph the square root of x minus 1 in y1, and you're going to graph x minus 3 in y2. And you are going to see a picture. Let's see, this is a square root graph shifted right 1, so it does one of these. And you could obviously, steal points off of your table. There's nothing wrong with that. What is wrong is what I'm about to graph, probably. Hey, you know what? That wasn't too bad. Go me. And then our secondary function, the other side of the equation, is x minus 3, which starts down here at negative 3. That is a slope of up 1 over 1. So, oh boy. Okay. So, this is the part that I'm a little concerned about. So, there's only one intersection point, which means there's only one solution to this question. The intersection point is an ordered pair, but you don't want the entire ordered pair, you just want x. So, the x equals 5 is the only solution. Which means this guy right here is extraneous, which I could have figured out by checking it in the algebra, but what we did is totally fine. In fact, I would kind of like to see all of that on your problem on your test as well. I want to see, basically it's a carbon copy question and process, so make sure you're doing the best you can. I'm going to leave 3B for you. Let's look at 4B. Oops, maybe not. Where'd 4A go? There it is. 4A, we're going to now read the directions. Solve by taking the square root. So we have to think about, okay, when I'm solving something through square rooting, I want to isolate the thing that's being squared. So my first step would be to subtract 60 from both sides. And I do notice we're going to have a negative solution before we square root, so that should tell you something about the type of solutions we're going to encounter. It's not time to take the square root yet. Oh man, look at me, wishful thinking, huh? It's positive too. Alright, so I'm going to divide both sides by 2. And we have x squared equals negative 25. Now, I'm very concerned about this question just because there's a lot of things that can go wrong right now. I know we're going to take the square root of both sides. I know we're finding x equals. I already wrote that part down for me. But what I'm very concerned about is children who forget that the solutions are both positive and negative at this point. And then how the heck do you reduce the square root of negative 25? So remember, guys, this is the stuff where you break it into 3 radicals usually. And you put your perfect square in the first radical. You put your negative 1 in the middle radical. And then if you have anything that's left over, you would leave it here. Well, this is a special case where you only have a perfect square and a negative 1. There is no leftover part to this question, so we don't need to put anything there. So the square root of 25 is 5, and then the square root of negative 1 we know is an I. So this is 5i, plus and minus 5i. So, this is old school of grading. If you forgot the plus or minus, you have the question wrong. If you forgot the I, you have the question wrong. If you didn't reduce the square root of 25, you have the question wrong. So make sure that when you're answering this, you're getting it 100% correct. 5a, we have a parent function of square root of x, and I want you to give me a new function that has been shifted left 4 units and then down 9 units. So we have to remember what that looks like, and if you want the complete function, we'll leave the shift for a off of it for now. But it's x minus any horizontal shift and then plus any vertical shift. So for us, going left 4 units means that underneath the radical, because remember the formula is x minus, so when you do a negative 4, that changes to a plus 4. and then down 9 units would be minus 9. So I don't really care how you get there, but remember, you have a graphing calculator, so if you're on the test and you're feeling like maybe you did that backwards, I would check it on your graphing calculator. Alright, here we got those word problems, and we need to kind of sift through all our information here, which means I probably want to, do some highlighting. I didn't want that to happen. There we go. That's what I wanted. Highlighter. Okay, on the first day, 3 senior citizen tickets, 1 child ticket for a total of $38. You might be going, hey, I feel like we just saw this question. Yeah, we did. These aren't very fun to make up, so sometimes I just steal the same question over and over again. Alright, so there's $52 on the second day, blah, blah, blah. This is the part I'm worried about right here, setting up your variables. So x and y are the 2 variables I want you to use, and then I need to know what they represent. So like a lot of kids will say x equals senior citizen, and I go, that's not good enough. You need to tell me what about the senior citizen. And then they say senior citizen tickets, and I go, not good enough. And then they say something silly like number of senior citizen tickets, and then I have to tell them, no, we already know the number of senior citizen tickets. So what do we not know? That's a variable. What we don't know is the cost of 1 senior citizen ticket. And I think when I keyed this, I kind of reversed my variables, but it doesn't really matter because my system will reflect that. So then y is going to represent the cost of 1, what do they call it? Student ticket, child ticket, child ticket. So very, very, very important that you have a very specific word in your definition of variable and that it's accurate. So the first day that they sold tickets, 3 senior citizen tickets costing X dollars plus 1 child ticket costing Y dollars equals 38. And then on the second day, the top cost was $52, and it was 3 senior citizen tickets and 2 children's tickets. And notice it doesn't say solve anywhere in the directions, it just says set up your variable, set up your system, and you are done. Alright, so again, some of us are still struggling with domain and range, so what I want you to get in the habit of doing from here on out, if that's you, is to use a highlighter for domain. We know it's where it starts on the left. Whoops, it goes to the right. That was supposed to be a straight line. I didn't do very well. Let's try that again. All right, there we go. That's not better. Okay, so domain reads from left to right. So start to finish, and our domain starts at -8 and ends at 3. Now because it ends at an ordered pair at a point, you need to make sure that you're using brackets on those intervals to indicate that the endpoints are also ordered pairs and include. And then we're going to do the same thing for range, and this is the one that kids usually mess up, so be careful. Range is low to high. Oh my gosh, it'd be nice if I could draw. So range, remember, it's backwards, so that's what gives everybody so much struggle. Oops. Oh, it doesn't like my sideways N. Okay. Whew, could not have been uglier. Low to high, and it starts at -4, and it looks like it ends at 4. So just get your bifocals out and read carefully when you do this interval. If you get the interval backwards, if you use the wrong brackets parentheses issue, you're going to have the question wrong, and that's kind of a shame because it doesn't matter if it's a small mistake or a big mistake. The point is it's a mistake, and you're going to get a loss of a point. All right, is it a function? Yes, this is a function. The reason is it passes the vertical line test, but you don't have to write that out. All right, 8a, this is on our graphing calculator. So what we're going to need to do first is get our parametric, well, it's not parametric, excuse me, our quadratic function typed into our calculator into, whoops, y1. So if you have a graphing calculator, please pause the video and get that done. Okay, so I have my function typed into y1, and of course we use the x variables instead of t. And then for the table, I would just go to the table to fill out by going second graph, and it should be in autofill mode, and then I would just copy the heights of the arrow or whatever we're doing this problem. Yep, for 3 seconds, 4 seconds, and 5 seconds. So here's 3 seconds, there's 4 seconds, and there's 5 seconds. So once you get the data entered back into your paper from the calculator, which I did not, let's see, the height was 279 feet. At 3 seconds, 307 feet at 4 seconds, and 303 feet at 5 seconds. Then it says, find the average rate of change from 3 seconds to 4 seconds. So what I would do is I would write these out as an ordered pair. So at 3 seconds, there's a height of 279. And at 4 seconds, there's a height of 307. And then average rate of change is basically slope. What am I doing? Rate of change. So what you do is you take the change in the height, which is y, and you divide by the change in the time, which is x. So for us, the change in the height goes from 307 minus 279, but since I know you guys are going to type this in your calculator, please use parentheses, and then divide by the change in the time. You got to go in the same order though. So we did 4 minus 3 then if we kept that order. So 307 minus 279 divided by 4 minus 3, or some of you just go ahead and simplify these and then just divide them separately, and this one comes out to 10 feet per second. Make sure you label, because you remember you're taking feet and dividing by seconds, so feet per second makes sense. Sometimes this number comes out negative, but that's because the arrow or whatever it is falling down. Right, so when we get to the next question, number 9a, we are graphing an absolute value function, which remember absolute value bars, if you want to find these on your calculator for graphing purposes, you go to the math menu, and then you go over to number, and then number 1 says ABS. And those are the absolute value bars. So just keep that in mind if you're ever stuck, but the vertex should be able to be found just by looking at the formula. Remember the formula is x minus h and then plus k. And then the other thing to remember about the formula is this a value in front that tells you what the slope of the branch is for absolute values. So the vertex for this particular absolute value is going to be located at -3 because of that built-in negative, and then +2, which means our transformations have shifted left 3 units and up 2 units. You don't have to talk to me about any other sort of transformations on this question. It's going to be pretty basic. So plotting our vertex at -3, 2, I notice that there's no number indicated in front of the absolute value, which means there's a slope, an a value of 1/1. For absolute value, that means you move up 1 unit, but then you move both right and left 1 unit. So up 1, right 1, up 1, left 1. But again, guys, don't forget you have a graphing calculator. So if you ever feel like, oh man, I think I'm doing this wrong, try that. I did a really bad job of what's new of graphing, but these should be V-shaped, not weird and curvy like mine just ended up. When we get to question 10, these are the questions where I'm trying to isolate for A, but I notice that there's multiple terms with a in the question. So the first issue we have to do is get everything with an a collected to one side of the equation. So I'm going to start by subtracting the 5a term over here. And basically we're just moving terms around. So on the left side you have am minus 5a. These are canceling, and it equals 4. So then I look at this side of the equation. I notice that there's a common factor of a that you're going to factor out of the question. So if you factor in a out of each term here, you end up with an m minus 5. So a times m minus 5 equals 4. And then your final step would be, I'm going to run out of room here, we're going to have to divide by the quantity m minus 5. You don't need the parentheses here, I just like to put them. So, final answer, a isolated is the expression for being divided by m minus 5. I kind of like those questions, but I'm weird. All right, moving on. The question on the test it's inspired by these questions, but what it's going to say is it's going to give you like a fraction expression. It's going to say which of the following are not equivalent to this. So basically you're going to have to simplify a whole bunch of things, and then the ones that are not the same as the original question, you're going to X them out. But for practice, let's just talk about all of our different exponent rules here. So first thing I like you guys to do is separate all the terms by putting little multiplication dots between them. I think it really helps your brain kind of kick in, especially if you're stuck. And then I think about simplifying this, and we always start with the coefficients and treat them like a little second or third grade problem. 10 divided by 12 is a coefficient problem. 10 divided by 12 reduces to 5/6. If you're never sure about that, always hit Math Enter to double check. Then what I'd like you to do is remember the rule for dividing is you're going to subtract the exponents. So 3 minus -9 would be x to the 12th. That answer, whatever it is, positive or negative, always starts at the numerator. And then y to the 7th is in the denominator, and it's going to stay there. So that's that. All right, next question. 5 dot y to the 9th over 3 times x to the negative 2. All right, so this next one, we're in the middle of the question, aren't we? We're not quite done. The x and y can't combine. However, anything with a negative exponent needs to move to the other side of the fraction bar. So this becomes still 5. Now it's x to the positive 2 power, still y to the 9th, and then you still have an over 3. I should be boxing in these answers or something. This is a mess. All right, so next one. I noticed in the parentheses there's nothing that's going to simplify, and then anytime you have a negative 1 exponent outside of parentheses, that just means everything's going to reverse to the other side of the fraction bar. So yes, you could distribute the negative 1 to everybody, but if you just remember what this means in exponents, it might save you a little time on the test. So the 2x to the 5th will end up in the numerator, and then the 7y to the 4th will end up in the denominator. So we're always looking to save a little time and energy on a test, aren't we? All right, this next one, again, if you want to save yourself a little time, instead of distributing the 1/2 power to everybody, think about what this means. This means you're taking the square root. So, whoopsies, come on, Bruzo. 10, work. So we have the square root of 25 over the square root of 49. And then the square root of x to the 8th is the same thing as multiplying these together, so that would be x to the 4th. And then square root of y to the 10th would be y to the 5th. But of course, that's not a good answer because you need to reduce the square root of 25 and the square root of 49. So this is 5x to the 4th over 7y to the 5th. There's our final answer. And then one for the road here. We have coefficients again. This time you do have some reduction. 5 over 50 is 1 over 10. When you math enter or divide those both by 5. I should not have drawn over that. That was my bad. X to the, remember we're going to subtract those. So x to the 1st always ends up in the numerator. And then y to the negative 4th always ends up in the numerator at first. But now, of course, we're going to have to move that. So the negative 4th power means it's going to move to the denominator. Some of you can do that without showing me that intermediate step, and you're awesome. But I'm a little worried on a test, so sometimes I try not to skip steps on that one. All right. All right, here's some what are essentially pretty basic factoring questions. They're going to be basic trinomials. Remember, they're reverse foiling questions. So the first term in your trinomial is the product of the first terms multiplied together. The last number is a product of the last numbers multiplied together. And the middle number are your arches, outside, inside, added together. So I always ask y'all what times what gives you x squared, and y'all shout at me x and x. And then we think about what times what multiplies to give you a 30. So, or sorry, negative 30, which means my signs have to be 1 plus and 1 minus. I know that. 30 could be a slew of things. It could be 5 and 6, 10 and 3, 15 and 2, 30 and 1. So then you think about your options, and we're trying to add up to the arches in the middle are trying to add up to negative 7. So I'm thinking, what if we had a negative 10 and a positive 3? Why did I use green? I wanted red. Because that would have this arch being a negative 10x, and this arch would be a plus 3x. And if we add those arches together, you get negative 7 in the middle. Perfect. So you guys are, I know some of you don't enjoy factoring, but you're very good at it. All right, this next one, we're completing the square, which means we're trying to write in vertex form. You're not allowed to touch the left-hand side. So x squared minus 6x, we're going to complete the square. Just going to kind of push the 20 off to the side. But here's where completing the square gets kind of weird on vertex form questions, because if you're adding a blank here and you're still on the same side, to keep it balanced, you have to subtract a blank. So the blank, remember, is your b term cut in half squared. So negative 3 squared would be a positive 9. But because this blank is on the same side, this is now a minus 9. And here's why it works. This quadratic now factors into x minus 3 quantity squared. And then these add together to give you a plus 11. So there's your quadratic in vertex form. The vertex is located at 3, 11. I don't know if they asked me for that, but I gave it to them anyways. And then our last question, I believe, is, oh yeah, it's a circle question. This time you're going to complete the square twice. So I'm going to grab the x's. They're already grouped together, but you're going to need to complete the square. And then we're going to do the same thing with the y's. And we're going to complete the square on the y's as well. The 24 is already moved over. But now let's balance out our equation by adding the blue and adding the green. Because you're on opposite sides this time, you're allowed to add both. So half of 8 squared would be 16. And then half of negative 6 squared would be a 9. And this works out beautifully because these all factor. So this becomes x, use the sign, x plus 4 quantity squared plus, and then be careful here, it's y, use the sign, minus 3 quantity squared equals, oh gosh, I should be able to add this, let's see, 30, 49. If they want to know the center and the radius, which they do. The center is located at opposite signs, negative 4, positive 3. And the length of the radius is the square root of this term, which is 7. Awesome. I think that question is multiple choice on your test. All right, good luck, everybody.